All right, these notes are going to be on section 1.2, different types of data. So we have a few different vocabulary words we're going to start with. First is a parameter, which is a numerical value that describes a particular characteristic of a population. And the second is a statistic, which is a numerical value that describes a particular characteristic of a sample. So populations have parameters, samples have statistics. And we're going to come back to these definitions in a little bit, but I just want to do a few examples. So first example, there are 250,342,875 adults in the United States. In a survey of 1,659 randomly selected adults, 28% of them said that they have a credit card. What are the parameters? What are the statistics? So for the parameters, we're looking at numerical values that are describing a particular characteristic of the population. So it looks like this is the population. It's the adults in the United States. And then the rest of it has to do with the sample. So the survey of 1,659 randomly selected adults. So the sample, not the sample, statistic. And then also the 28%. Okay, the next example says the average ACT score for the nation last year was 21. Is this a parameter or statistic? So we have to determine whether that 21 is talking about a population or a sample. Which is it describing? And it says for the nation. So I would say this is probably a parameter. And that's because 21 describes the ACT or the average ACT score of the nation, which is likely the population. It's possible for the nation to be a sample if the entire world was the population, but the ACT, to my knowledge, is specific to the United States, I believe. All right, next example. In a study of 400 babies born at 4 different hospitals in New York, it was found that 51% of them were girls. Is this a parameter or statistic? So in this case, we're talking about the 400 babies. And that's at specific hospitals in New York, so this is probably a sample, unless they specified somewhere in the question that 4 different hospitals and the babies in those hospitals were the only thing they wanted to study. They didn't want to look at anything else. Then these are probably just the samples, and they're looking at hospitals of New York in general. Hopefully just of New York, but it could be that they only looked at New York hospitals and they're talking about hospitals of the United States in general. So this is most likely a sample, which means that this would be a statistic. And we have 2 numbers here. We have a sample of 400 babies, and 51% were female. So statistic, the Those are the two statistics. From the context, we are likely expecting all New York hospitals to be the population. Okay, the next two vocabulary terms that we're going to look at are quantitative and qualitative. Quantitative is numerical data, and this is data that consists of numbers that represent measurements. So here in quantitative data, you are always going to see a unit of measurement that describes this data. So it could be inches, it could be pounds, it could be the number of something if you're counting, but there's always going to be some sort of unit involved in the measurement. Qualitative data is categorical. So this is data that consists of labels that represent measurements. So you're going to describe the data based on its attributes, not using units of measurement, but describing what you're looking at. So let's do some examples here as well. Suppose you go to a Starbucks and order a drink, list some data that is quantitative and some data that is qualitative. So for example, you could look at the size of the cups. And you could do this quantitatively as well as qualitatively, depending on how you measure the data. So you could look at the size of the cups in ounces, or you could look at the size of the cups. I'm going to write by name. And at Starbucks, that would be tall, grande, and venti. Venti? So one has a unit of measurement, ounces, the other is just their attributes, what they're called. Another quantitative data could be the number of pumps of flavoring syrup. You could talk about drinks that have 2 pumps, 3 pumps, a half a pump. The qualitative data could be the different flavors themselves. So you could talk about vanilla, you could talk about hazelnut, chocolate, etc. You could talk about the temperature of the beverage in degrees Fahrenheit, or you could talk about a hot or iced beverage. So take a moment, pause the video, see if you can come up with maybe one other piece of data, quantitative and qualitative, one for each of those. Okay, let's turn to the next page. The next page is asking you to come up with characteristics, types of data, quantitative and qualitative, that you could find out about students in this class. So quantitatively, numbers that have units, we could look at all the students, we could find their height in inches, or we could find their height using categories, and we could talk about whether they are short, average, or tall. We could talk about everyone's age in years. We could talk about the birth month for each student. We could talk about class schedules using their number of credits, the number of credit hours that you're taking, or we could do class schedules and look at the subjects that each person is taking. Go ahead and pause the video and take a moment and add a couple more quantitative types of data and qualitative types of data that you could be measuring. Okay, if we go back to the first page, we have two more vocabulary terms, and these are discrete and continuous. Discrete is data that describes a finite or countable set of quantitative values, so these are numerical. Continuous is data that describes an uncountably infinite set of quantitative values. And typically the way that you're often going to see these is discrete are oftentimes whole numbers. They don't have to be, but oftentimes you're going to see them as whole numbers or pretty simple decimals, like half, 1.5, things like that. And then continuous data is going to be data where you're going to see decimals in between the numbers, and decimals that can become more and more precise, that can have more and more detail. So that's what they mean by infinite. Not that the numbers get bigger and bigger and bigger, but just saying that the precision can become more and more and more accurate. You can have more and more decimal places to describe that data. Okay, so we're going to turn to this page and look at whether or not the data points would be discrete or continuous. So is the time it takes someone to run a marathon discrete or continuous? And that would be continuous. And that's because you can talk about time using hours, you can talk about using minutes, seconds, and then you can get 1/10 of a second, 100th of a second, 1,000th of a second. You can always get more precision as you get more sensitive timing instruments. So this is going to be a continuous measurement. Suppose a college wants to determine the average class size. Will the data collected be discrete or continuous? So this one was time. Here we're talking about the average class size. This value is going to be discrete. And that's because when you're talking about the average class size, you're talking about human beings. And those are going to be whole numbers. You can count 5 people, you can count 7 people, you can count 20 people. You can't count 1.75 people, 1.752, 1.7523. It's always going to be 1 person or 2 people. You're not going to have any decimals for in between. So this is measured in number of people. Which is limited to whole numbers. Is the number of coin tosses required to obtain heads discrete or continuous? So you're tossing a coin, you get tails, 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 then heads. Or you're tossing a coin, you get heads the first try. Or you're tossing a coin, you get tails, then heads. So is the number of coin tosses discrete or continuous? The answer is discrete, because our answers there cannot become more precise. It's either 1 toss, 2 tosses, 3 tosses. You're not going to have 1.25 tosses or 1.257 tosses or 1.2579 tosses. You just have 1 toss or 2 tosses, nothing in between. And then last, is the lifespan of a light bulb discrete or continuous? The lifespan of a light bulb is time. You just measure it in time. So this could be hours, probably months, days, and then hours. It's time, and so it's always going to be something we can get more precise with. And so this is continuous. We can definitely have more and more precise measurements, more and more decimal places of accuracy if we would like. All right, next. We have different levels of measurement as we organize our data. So nominal levels of measurement organizes the data by name, label, or category. There's no particular way to order this data. So there's not a set organizational pattern. It just kind of, you organize it into your different categories and then you put them in the order you want that makes sense to you. Ordinal arranges data in a particular order, but the differences between the data values are meaningless. So there might be numbers to represent the data that you can put in numerical order, but the numbers themselves don't really have meaning. Or there might be something you've got in alphabetical order, but the alphabetical order itself doesn't have meaning. Next is interval. You arrange the data in a particular order. Now you have differences between data values that can be found and have significance. So it's not meaningless. There are differences that make sense. However, there is no natural zero, which means there's no starting point. There's not a point in the data where it makes sense to start the number, or there's an absence of that data point, or there's an absence of that quantity. The ratios between the data are meaningless. So the way that the numbers relate to each other is meaningless. And then last, we have the ratio level of measurement, which arranges data in a particular order. The differences between the numbers have meaning. The ratios between the numbers have meaning. They relate to one another, and it has significance. There is a natural zero or a starting point where none of the quantity is present. All right, so as we go through examples, you take the example and you just walk through each of these and see what is true and what parts it's missing, and then that's where you land. Okay, so for the first one, it says left or right-handedness of students in the class. That's a name, label, or category. It's not a value. It's not values that have to be in a particular order. You could put left first and then right, but if somebody wanted to put right first because there's more right-handed people in the world, it would kind of make sense to put right first and then left. So this would be nominal levels of measurement, and that's because there's no predetermined way to order the data. All right, next we'll look at shoe sizes. So if we consider shoe sizes, we can go past the way that they're labeled because there is a particular way that you should order this data. Their shoe sizes are numerical. So you can arrange the data in a particular order. In fact, there are differences between the data values that can be found. So there's a difference between a shoe size of 7 and a shoe size of 8, and the differences between those shoe sizes have significance. So a difference between an 8 and a 9 and a 10, a 10 and an 11. There are differences that make sense. There is no natural zero. We can see that that is true. There's no such thing as a shoe size of 0 where none of the quantity of a size of shoe is present. So if you're describing the sizes of shoes of people, there's not a point where you would say that person has no quantity of shoe size. That just Seems silly. So if this one says that there is no natural zero and the ratio definition says there is a natural zero, then we're going to have to go with interval. All right, next, the amount of money that's in your pocket. So this one, your data is going to be in a particular order. It's definitely numeric. Here, there's differences between the data. I know the difference between $5, $10, $15, $20. Ratios are going to make sense. So if somebody has $10 in their pocket, somebody else has $20 in their pocket, I know that what twice as much money means. And there is such thing as a natural zero. There's a point where none of the quantity is present. There's no amount of money in your pocket. So this would be an example of a ratio. All right, next, the letter grades a student earns in a course. So here we do have a particular way that we can order the data, A, B, C, D, F. However, the differences between the data, they are kind of meaningless if you're talking specifically about letter grades and not percentages. If I'm talking about 90%, 80%, 70%, then I can talk about the differences between the data. But if I'm talking about an A, a B, and a C, there's nothing, it doesn't make any sense to say a B minus a C or a C minus a B tells me something about a quantity. It doesn't. It only does if you talk percentages. So the letter grades that a student earns in a course would be ordinal because it does not meet this requirement. All right, the amount of time spent on homework each day, these are numeric values, 1 hour, 30 minutes, 5 hours. So we can arrange the data in order. We can have differences between the data. There is a natural zero. There's a point where you could have done zero homework. Ratios make sense. One person does an hour of homework, somebody else does 2 hours of homework. That's twice as much. And so the amount of time spent on homework each day would be ratio. Survey responses of yes, no, and unsure. I could put the yeses first and then the unsures and then the nos. I could put the yeses first and then the nos, then the unsures. I could put the nos first, then the unsures, then the yeses. It makes sense to categorize these, but it doesn't, there's no specific order we have to use for those. And so this would be nominal. There's no particular way to order the data. Your satisfaction rating for this course on a class evaluation. These could be labeled from 1 to 5, so there is a particular order that would make sense. The differences between the data values are probably meaningless. So I know there's a difference between a 3 and a 4, but if I subtract those numbers, 4 minus 3 is 1, what's the numeric value of a 1 in terms of how you feel about a class? Maybe they've defined it as neutral versus somewhat satisfied, but there's not any inherent meaning in that number by itself. And so here we would say that this is ordinal. You can put the numbers in order, but when you subtract them, those numbers specifically don't have meaning. Next is dates listed by year. So if you put the years, you could put them in order, certainly. So we know you can arrange those in a particular order. We know if we subtract years, there's some value in that. We could say there's 5 years in between, 10 years in between. But there is no natural zero. There's not a point with dates where you just have a zero and then the quantity of the date ceases to exist. So even if you have like the date 0, you're still talking about BC or AD, but there is no natural zero where none of the quantity is present. And so for that one, we would say interval, because there is no natural zero.